Hello students, we are continuing with our sixth lesson, physical and chemical changes. Before starting today's portion, I want to make it sure whether you have all watched the previous video or not. And in that, I explained about the symbols and molecular formula. Now you are going to learn about chemical change. And in chemical changes, many chemical reactions are shown, equations are shown, and if you want to learn them properly, you should know the symbols of the elements. So before watching this video, everyone should watch the previous video and learn the symbols. Okay, now today we are going to discuss about chemical change. Children, you all might have seen a brownish yellow colored powder on the iron object that is kept out in open or in the moist places. This powder like a substance you can see on the grill of the windows and also on the iron gates of the parks, not only in the park, anywhere on the iron gates and the agriculture tools and any object that is made of iron, if it is kept outside in moist places or in wet places, you can see this brown colored powder. And do you know what is it? It is rust. The common name is rust. And actually it is the compound of iron. It's the oxide of iron. And the chemical name is iron oxide. And iron oxide is formed by the reaction of iron with the oxygen. And about this iron oxide and what is to be done to prevent rusting and all, you will be learning in detail in the coming days. Now we will discuss about an activity to show the chemical reaction. And the formation of iron oxide is a chemical change. And before discussing more about how it is formed, we will see another activity here. And here, this is how the magnesium oxide is formed, that is given as an activity. It's an important activity. You have to learn. It can be as well as an experiment also. See, take a ribbon of magnesium. Magnesium is one of the metal. And the symbol of magnesium, yesterday's table it is given, it is Mg, capital M and small g. Mg is a symbol of magnesium. So take a small piece of magnesium ribbon. Then clean it with a sandpaper. Then bring this ribbon near the candy flame. If we brings it near the candy flame, it will burn with a brilliant white light. And when it is completely burned, it leaves behind a powdery ash. You know, any object like a paper or anything, when it burns completely, you will be getting the ash. Same way, when we burn the ribbon of magnesium, how to burn it? We will take a piece of magnesium ribbon and clean it with a sandpaper. Then bring it near a burning candle flame. Then it starts burning. And when the ribbon completely burns, it leaves behind a powdery ash. Now, one caution is given here. It is dangerous to look for a long time at the burning magnesium ribbon. Why? When we burn the magnesium ribbon, it is dangerous to look at the burning magnesium ribbon. Why? Because on burning magnesium, it gives out immense light and heat. Too much heat and light energy is produced. And if we look continuously at the burning flame of magnesium, it can cause temporary loss of eyesight. So it is not advisable to look at the burning magnesium ribbon for a long time. Okay, in the picture you can see too much light you can see outside this burning of magnesium. Okay, so when the magnesium ribbon burns completely, you collect the ash. What is it? It is magnesium oxide. And magnesium oxide is formed by burning magnesium in presence of oxygen. And oxygen is necessary for burning of any substance. Okay. And magnesium oxide is the new compound formed here. So it is an example of a chemical change. In a chemical change, a new compound will be forming. And here magnesium burns in air and gives magnesium oxide. And this change is represented by the equation. That only I told you should learn the table yesterday's table, then only you can understand what is formula and symbols and all. Magnesium symbol is given here Mg. Magnesium, it burns in air, burns in presence of oxygen, and oxygen symbol is O. But oxygen is a diatomic molecule. So whenever we write oxygen, then you have to write 2 also down. So magnesium plus oxygen gives magnesium oxide. The new compound is magnesium oxide, and formula of magnesium oxide that was also shown in yesterday's table, MgO. See, M capital, G small, and O capital. Understood? So when we burn magnesium, it gives a new compound called magnesium oxide. Now, collect this ash and mix it with a small amount of water. Stir the mixture well. So what we have to do now? Now collect the ash of magnesium, that is magnesium oxide, then mix it with a small amount of water, and we will get a solution, that is magnesium hydroxide. That means when magnesium oxide is dissolved in water, it will form another compound, that is magnesium hydroxide. And magnesium hydroxide is a base. What is the formula of magnesium hydroxide? MgOH twice. See, magnesium oxide plus water gives magnesium hydroxide, that is MgOH twice. This formula, properly listen to me. Magnesium oxide is MgO, and water formula H2O. Magnesium react with water and gives magnesium hydroxide. Magnesium hydroxide formula yesterday's table I have given OH group. OH group is hydroxide group. MgOH twice. MgOH twice. It is 2 times. So we have to read it as MgOH twice. Understood? How to produce magnesium hydroxide? We will take a piece of magnesium, clean it with the sandpaper, then we will bring it near a candle flame. When it burns completely, it will leave behind a powdery ash. We will collect the ash and dissolve in a small quantity of water. Then we will be getting, the solution is magnesium hydroxide. We will get a magnesium hydroxide. 2 formulas, 2 equations you learned here. First, magnesium plus oxygen gives magnesium oxide. That is Mg plus O2 gives MgO. Now second formula, MgO plus water. MgO is magnesium oxide plus water. Water formula H2O. So MgO plus H2O gives MgOH twice. Now, what type of compound is magnesium hydroxide? And in the last lesson, you learned about acid and base and all, right? Hydroxide group is bases. Remember, if any compound is ending with hydroxide, potassium hydroxide, sodium hydroxide, magnesium hydroxide, they are all bases. And what are the properties of bases? We know clearly, it is given in the very important also to learn it. Bases turn red litmus paper blue, and it has no change in the blue litmus paper. It will not make any change in the color of the blue litmus paper, but it changes the red litmus paper into blue. So how we will check that the magnesium hydroxide is base? For that, you will dip a red litmus paper in the solution. When you dip the red litmus paper, the color of the red litmus paper will be changing into blue. So red litmus paper changes to blue. That means it is a base. And if you dip a blue litmus paper in the solution, it will not make any change in the color of the blue litmus paper. That way we can prove that the compound formed is a base. That means magnesium hydroxide is a base. So in this reaction, the formation of magnesium hydroxide from the magnesium ribbon, you are going to learn 2 equations. Again, I am repeating. Magnesium plus oxygen gives magnesium oxide. Formula Mg plus O2 gives MgO. This magnesium oxide is a new product forming. Now, second product is magnesium hydroxide. So what is the equation? MgO plus H2O gives MgOH twice. So magnesium oxide and magnesium hydroxide. These are the two new compounds formed in this reaction. So it is a chemical change. For that we can conclude that new compounds are formed in a chemical reaction. Already in the first video I explained about the physical changes, and in physical change I have given the main points in the last. And what was the last point given? No new substance is formed in a physical change. The physical change will not be making any new product, new compound. But in chemical changes, new compounds will be, or new products will be forming. Okay. One more example is given as an activity that is also very important activity that we will discuss in the next video.